Okay, so in this section, we're talking about operations with matrices. Okay, so in this example, it says to solve for the following elements in the following matrix equation. So it's already telling us that they're equal, but the only way that they're truly equal if the dimensions are equivalent. So this is 2 rows, 2 columns. So this is a 2 by 2 matrix. And so is this one. So because they are both 2 by 2 matrices, then we are able to say the element that's a row 1, column 1 is equal to this element that's in row 1, column 1 is 2, and a row 1, column 2, and the corresponding element here is negative 1. Element that's row 2, column 1, corresponding in this matrix is negative 3, and row 2, column 2 is 0. Okay, so now what we're going to do is we're going to take two matrices, add them, get a new matrix, or multiply the matrix by a scalar. Let's take a look at an example. Okay, so in the following example, we're adding the following matrices. And so in our first example, remember, we match up the elements that are in the same row and same column. So negative 1 is going to pair with this positive 1 in my new matrix. Negative 1 plus 1 is 0. Here I have this 2 and a 3 that's in the same row, same column. So 2 plus 3 is 5. And now we have 0 plus negative 1, so that's negative 1. 1 plus 2 is 3. So pause the video, try B and C. So the following should be your answers. Remember, we're going to match up elements that are in their corresponding rows and columns. And our following solution is 0, 1, negative 2, 1, 2, 3, because we added zeros to each of these elements. And here, 1 minus 1, 0, negative 3 plus 3, 0, negative 2 plus 2 is 0. And now I want you to think about these two matrices based on the last few slides that we looked at. Are we able to add the following two matrices? Well, let's take a look at the dimensions here. This is a 3 by 3. And this is a 3 by 2. Because it's not the same order matrix, or the dimensions don't match, I'm not able to add these matrices, so we would say that this is undefined. So if you think about it, the following properties of matrix addition and scalar multiplication are applicable. We have the commutative property, where the order doesn't matter. We have the associative property of matrix addition, where I can group the first two, then add the third one, or I can group the last two and add the first one. I have the associative property of scalar multiplication, so either I can multiply the first two, then this is only a scalar multiplication. I have a scalar identity, multiply everything by 1, I still get the matrix I started with. I can distribute a scalar, or I can distribute a matrix. All right, so this is from your textbook, so let's take a look. This is section 10.2, matrix operations. So here we want to find x and y. So let's take a look at this first problem. So based on what we've talked about so far, the dimensions are the same, they are equivalent, so we can say x is negative 4 and y is 22. So that would be the solution here. X equals negative 4 and y equals 22. And we would do something similar on number 10, except we have a little bit more manipulation here. Here we have x plus 2 equals 2x plus 6. So x plus 2, let's zoom out a little bit. X plus 2 equals 2x plus 6. And then I would go ahead and solve that. And we're also solving for y. So 2y equals 18. Then we have this here, y plus 2 equals 11. And we have 2x and negative 8. 2x equals negative 8. So the solution here is y equals 9, which is consistent when I either divide 18 by 2 or subtract 2 from 9. Here, when I divide x negative 8 by 2, I'm going to get x equals negative 4. I'm going to subtract x on both sides. And I'm going to subtract 6, and I'm going to get x equals negative 4. So the solutions are consistent. It didn't matter which elements I went to find those answers. Okay, so this is very similar to what we were looking at before. We're just going to add a and b or subtract a and b. So I'm actually just going to skip a and b and take a look at the scalar multiplication c and d, because I did not do that in a previous example. So let's take a look at that for number 13. Okay, so now we're going to take a look at C for number 13. We just want to find 3 times A. So what that means is I'm just going to distribute 3 to every element that's in here. So 8 times 3 is 24. 2 times 3 is 6. Negative 4 times 3 is negative 12. Negative 1 times 3 is negative 3. 3 times 3 is 9. 5 times 3 is 15. So that's how you do a scalar multiplication, like I was talking about in a few other slides. Then we want to do 3a minus 2b. Well, we already have what 3a equals, so what we could do is find 2 times b and then subtract them. So let's go ahead and do that. Twice b is going to equal 2 times 1 is 2. 2 times, and I'm looking over here, 2 times negative 1 is negative 2, 2, 12, negative 10, and 20. So now I want to subtract these two. So now we're going to do 3a minus 2b. And make sure you're doing the order of operations. So it's 24 minus 2. My answer is then 22. Negative 3 minus 12 is negative 15. 6 minus negative 2 is 8. Negative 12 minus 2 is negative 14. 9 minus negative 10 is 19. 15 minus 20 is negative 5. And that's how we do matrix operations. So this is part 1. I will continue part 2 in my next video lesson, and you can catch that tomorrow.